Hey everybody, welcome to this video. This is the video for Module 35 for Business Math and Calculators. In this video, we are going to talk about compound interest. In the last video, we focused on simple interest, so here we're going to talk about what happens when interest is compounded. Just to give you a heads up, the example problems that we do in this video are going to focus on how to use the formula for calculating compound interest and the future value of an investment. In class, we will talk not only about the formula, but also other methods, such as using tables and other things like that to do the calculations. So I just wanted to give you a heads up that we're going to focus on using the formula here, but we'll talk about other methods as well when we meet each other in person. With that, I'm going to share my screen and we are going to jump into several examples. Alrighty, compound interest. Here we go with example problem number 1. So what you've got is a situation where we are depositing $3,000 into a savings account. The annual interest rate is 2.5%, but it's being compounded quarterly. All right, so keep in mind the idea of quarterly. We'll talk about that over here in just a second, what that means. The amount or the amount of money that's put in the savings account lives there for 2 years. So we want to figure out how much money will actually be in the account after the 2 years, assuming we don't add in any more deposits. Okay, so essentially what we want to figure out is what's called the future value of the account, the future value of the investment, which will be the original principal plus whatever interest has been earned on that investment. Now, to get started, let's focus on our formula for calculating the future value, or the amount that is in an account after interest has been added in and has been compounded. Now, I know you might look at this formula and be a little worried about it because it is pretty complicated. There are lots of variables in it. There's lots of operations. There's exponents, there's parentheses, there's fractions. I know it looks kind of scary and kind of messy, but once you get the hang of it, it actually works pretty slick as far as doing calculations. And the nice part about the formula is that it can be used in any situation, no matter how often interest is compounded, no matter how many years the loan or the investment lasts for, no matter what the interest rate is, it can apply in any situation. And so if you get comfortable using the formula, it can be a faster way to complete calculations involving compound interest. Now, with that said, let's go ahead and rewrite our formula here with the values from the problem. And we'll talk about what each value is and where it goes in the formula here as we look at the next step. So we start by writing in what the principal amount is, or that initial amount that was deposited. So $3,000 goes in for the principal. In the parentheses, the 1 that's there is just part of the formula, 1 plus, and then in the fraction, R over N, R is the interest rate, written as a decimal, so make sure you convert 2.5%, move the decimal point 2 spaces to the left to get the 0.025. N is the number of times the interest is compounded in a year. So since it's being compounded quarterly, what that means is every 3 months, interest is calculated and added to the balance. Every 3 months would allow us to compound the interest 4 times in a year. Okay, so think quarter, 4 quarters in a dollar, 4 quarters in a year. 4 is the number of times it'll be compounded. So that's where the 4 comes from when we plug that in for N. All right, in the exponent, there are 2 things that are multiplied together. One of those is the same value for N, so 4 again, and then T, like in simple interest, is the time in years. So again, we've got 2 years, so that's going to be our value for T. Now, once we get everything kind of plugged into the right spot in the formula, now it's just a matter of doing the simplifying and coming up with what the solution is. Here you want to make sure that you carefully follow order of operations as you simplify. It's a good idea to show your work. Don't try to do too much in one step. Because it can get a little bit, messy if you try to either do too much in your head or try and, just punch it all into your calculator and hope that it works out. Write down the steps that you go through to keep track of the numbers. Now, in this first step for simplifying, I've actually done 2 things. Number 1, I simplified the exponent. 4 times 2 is 8. So that's taken care of for the power. And then inside the parentheses, I simplified that fraction into a decimal number by dividing 0.025 divided by 4. So that gets you 0.00625. All right, now let's continue simplifying. We want to simplify what's inside the parentheses, so I'm just going to add 1 plus that decimal. So that's all we did in that step. The next thing to then do is take care of the power. So I'm going to take 1.00625 to the 8th power. Definitely want to use your calculator on this. Don't do this by hand because the decimal is going to get ugly fast. There's going to be a lot of numbers involved. As you can see, when we do that, we get 1.051107, and that decimal actually keeps going on. So when you do this, don't round off too much too early. Save the rounding for the last step, essentially. So I recommend writing out your decimal, 4, 5, 6 decimal places. That'll help ensure that our final answer is as accurate as possible. If you round off too much, your final answer might not be as accurate as it could be. So just keep that in mind. Last step is to take that weird decimal, multiply it by the 3,000, and we end up with 3,153.32. Because we're dealing with money, it makes sense to round the answer to the nearest hundredth because that's cents, dollars and cents in this situation. So that's why we came up with that answer. Again, the decimal itself is actually keeps going on, but rounding here is definitely appropriate since we're talking about money. And when all said and done, let's make sure we answer the question, what amount of money will be in the account? It is the $3,153.32. All right. So when you look at this situation, look at this answer, essentially what we can conclude is based on the compounding that was happening in this problem, the account earned $153.32 in interest. And so if you were to go and withdraw the money, you would get the original 3,000 plus that interest. So you've actually made a little bit of money over that time, which isn't a bad deal for just putting your money in and not really having to do anything other than just let it sit there. So kind of a cool deal, I guess, in that regard. So there you go. There's our first example for calculating the compound interest and the future value of an investment. All right, let's jump to a second example. So this time, Leo is making a deposit, $5,000, into an account that earns 4% annual interest. This time, though, we are compounding the interest monthly. All right, so we want to figure out how much money will be in the account after 5 years. So again, we're going to go back to our formula, and we need to just start plugging in values. Okay, so when we do that, the initial amount, the principal, is $5,000. The annual interest rate, R, is 4% written as a decimal, 0.04. Because we're compounding monthly, what that means is the interest gets calculated and added to the balance 12 times in a year. All right, so that means N is going to equal 12 because we're compounding it 12 times. Okay? In the exponent, again, N is 12, and the number of years for this investment is 5 years. So again, the T is always a value written in terms of years. Okay. Now that we've done this, we want to go ahead and do our calculation. So the first thing I'm going to do, 2 steps in this process. Number 1, simplifying the fraction into just a decimal. So 0.04 divided by 12 gets you 0.00333, and that actually continues on. But again, you can round a little bit, just don't round too early, too often. Write out enough decimal places to make sure that you've got a good handle on what that decimal is. And then we also simplify the exponent. 12 times 5 is equal to 60. Again, you want to use your calculator to do this calculation. If you have to multiply in this next step 1.00333 60 times, you might get a little tired. Your hand might get tired. You might run out of room on your calculator, and it's just a big waste of time. Use your calculator to simplify the exponent next. Again, you're going to get a weird decimal, so write down the decimal out to 4, 5, 6 decimal places at this point. And then finally, we need to multiply. And so we come up with $6,104.98. Again, it makes sense to round off that multiplication, that product, to the nearest hundred since we're talking dollars and cents. Again, we wanted to figure out how much was in the account, so we want that future value, interest, and principal put together. So we have the final answer of $6,104.98. And there you go. We are all set. All right, let's do one final example problem. All right. This time, we are going to use the formula in reverse. We're going to work backwards here a little bit. So it says Darla is planning for her retirement, and she wants to have $250,000 available to her when she retires in 25 years. So what she wants to do is she's going to invest some money in an account that happens to earn 5% interest compounded semi-annually. So we want to figure out how much she needs to invest. So we want to figure out what principal needs to go into the account and then sit there for the 25 years earning interest. So that way, when all said and done, the account has the $250,000 in it. All right. So here's our formula. Again, what's nice about the formula is you can use it whether you are calculating future value or some other variable in the equation. So in this case, we're going to try and find P. That's what we're going to solve for. So let's plug in some values. So 250,000 is the future value we want to get to, so that goes on the left. The variable is P for principal. Inside the parentheses, 1 plus, the rate is 5%, so 0.05, written as a decimal. Because we're compounding semi-annually, that means twice a year. So 2 times in the year is when it gets compounded, so 2 goes in the denominator for n. In our exponent, again, n is 2, and we're going for 25 years. So she's going to let it sit there for a long time while she's working, waiting to retire. All right, now we just need to do some simplifying and solving. So with that, let's take care of the simplification. So the first thing that I did here is, number 1, we simplified the fraction. So the 0.05 divided by 2 got us the 0.025 in the parentheses. And then 25 times 2 is 50. That's the number of times the interest is going to be compounded over the life of the investment. All right, now the next step is we need to simplify inside the parentheses. So 1.025 now is in the parentheses. Next step, take the 1.025 to the 50th power. Use your calculator to do this, and you'll get a weird decimal. So we end up with $250,000 equals P times the 3.437108. Again, write the decimal out quite a ways, just that way we know our final answer is going to be as accurate as possible. And now I need to just solve this mini equation. So we have a lot of simplifying going on to get it to this point. I need to get P by itself. So what we need to do is divide both sides by our decimal number, the 3.43. When I do that, 250,000 divided by 3.437108 gets us an amount of 72,735.55. So what this means is Darla needs to invest $72,735.55 if she puts that into this particular account and lets it sit there, doesn't add any more to it, just lets the interest compound and add to that over time. After 25 years, it'll grow from the 72,000 approximately all the way up to 250,000. So there you go. All right, so compound interest. So again, we did 3 examples. Hopefully they were helpful in illustrating the use of the formula for calculating future value and calculating the amount of interest that is compounded and added to an account. The key thing to keep in mind with compound interest and what makes compounding different than simple interest is simple interest always just adds in an amount based on the original principal. So like every year, interest based on that principal is added in. With compounding, what's really interesting is as interest gets added into the account, the next time interest is calculated, the calculation is based on the original principal plus that new interest that was added in. So what happens is the amount of interest grows over time that's being added in, and so you can get to larger amounts for the future value quicker than if you're doing just a simple interest kind of situation. And so compounding has its pros and its cons. You know, if you're investing money, it's great because you're earning that interest. If you're borrowing money, then you're having to pay more interest. So it kind of depends on the situation. What you'll find as we move forward is you'll see a lot of situations where, you know, you're doing investments or you are taking out loans where compounding is what is used to do that calculation. So just be aware that compound interest is a pretty common thing and is used in a lot of different situations depending on, you know, what's going on, you know, in terms of borrowing or investing or different things like that. I hope that this video was helpful in illustrating the use of the formula for the compound interest. If you have questions, please do not hesitate to let me know. I am always happy to help. And with that, I hope the video was helpful. I appreciate you taking the time to watch the video. Let me know if you have any questions, and I will catch you in the next video.